All right, so let's take a look at example 3. We're going to run through this process just like we did in the previous videos. You're going to have to think about, what happens before you factor. So what's our y-intercept? Remember, the y-intercept is what we get when we plug 0 in for x. So if I plug 0 in for x, I'm going to get 0 squared minus 4 times 0 plus 3 over negative 2 times 0 squared minus 2 times 0 plus 24. Now that's 0 minus 0 is 0, and then 0 minus 0 again is 0. So we end up with 3 over 24, which is just 1/8. So my y-intercept is the point 0, 1/8. Horizontal asymptotes. So we compare the degrees of the numerator and the denominator. So we see in the numerator, my highest degree, my highest power is 2. In the denominator, my highest power is also 2. If you think of a 1 being here in front of our x squared, then when we look at the ratio of those coefficients in front of the highest powered term, we see that our horizontal asymptote, it will be horizontal, is going to be negative 1/2. So we would have y equals negative 1/2. Now we have to factor. So we'll run through that factoring process. The first part of this, the top should be pretty easy to factor. I don't think there's any issues there. Won't really talk too much about that because you should be able to factor that one pretty quickly. The bottom, however, we're going to need to start by factoring out a GCF, and that's something we should always be looking for. And because my leading term was negative 2 as a coefficient, I'm going to factor out a negative 2. So that's going to leave me with x squared plus x minus 6. And then I can factor that trinomial as well. So when I look at my final factorization, I'm going to have, so this will be plus 3 minus 2. All right, so now I've got this factored. I can start to compare or start to look for some things in the rest of the process here. So next up, we're going to look for a hole in the function, and that comes from any factor that can be reduced as a giant 1. I don't have anything here, so I don't have any holes in the function. All right, and then my x-intercept. So the x-intercept comes from looking at your numerator and saying, hey, what would make each one of these factors 0? Essentially, if you're having trouble doing that, really what you're asked to do is take each of those factors in the numerator, so x minus 3, set it equal to 0, and you get x equals 3. And then take x minus 1, set it equal to 0, and solve, and you get x equals 1. That's going to tell me where my intercepts are. So my intercepts are going to be at 3, 0, and 1, 0. So then vertical asymptotes come from looking at the denominator. So I'm going to look at each of those factors and all 3 factors really. So if I take negative 2 and set it equal to 0, that doesn't make any sense. So that doesn't actually give us any usable information. But if I take x plus 3 and set it equal to 0, I get x equals negative 3. And if I take x minus 2 and set it equal to 0, I get x equals 2. Those are my 2 vertical asymptotes. So x equals negative 3 and x equals 2. Now, when we write the domain, remember the domain is very closely related to any holes or vertical asymptotes in our function because we're looking for those excluded values. So that's going to be no holes in the function, so we go from negative infinity to negative 3, from negative 3 to 2, and then from 2 to infinity, right? And that negative 3 comes from this asymptote, that 2 comes from this asymptote, and because we didn't have any holes, we don't need to worry about that. And then our end behavior comes from our horizontal or slant asymptote. So we say as x approaches negative infinity, y approaches, and remember, we're just figuring out what goes there. And then as x approaches positive infinity, y approaches something. And that something is always directly connected to whatever we've written up here. So it's going to approach negative 1/2.